Good morning, my dear students. So yesterday we discussed minimum spanning tree algorithms. So what are Prims algorithm, Kruskals algorithm? Okay. Yesterday we discussed. So what is a Prims algorithm? What is Kruskals algorithm? So why are you using those algorithms? Those algorithms are used to minimum cost spanning trees. Am I right or not? Minimum cost spanning trees. Here simply minimum cost spanning tree. Simply we want to find a spanning tree from a given graph. From a given graph. So graph is a connected components. Yes or no? So whereas tree is an unconnected components. Am I right? So then here simply minimum spanning tree. So in the minimum spanning tree of an undirected graph is a tree. So formed from graph edges that contains all vertices in the graph at lowest total cost. Lowest total cost. Which is the lowest total cost edge? Which is the lowest weighted edge? We should go like that. Okay. Then here properties of minimum spanning tree. Every vertex is included. The total edge weight of spanning tree is the minimum possible that includes a path between any two vertices. Am I right? So then we may not use edge that would produce a cycle. If there are duplicate weights, there may be one or more minimum spanning trees. Yes, application minimum spanning trees used in network design, traveling salesperson problem. Traveling salesperson problem. This is the first one is the Prims minimum cost spanning tree. Prims minimum cost spanning tree algorithm. Prims minimum cost spanning tree algorithm. All of you. So in the Prims minimum cost spanning tree algorithm, Prims algorithm is used to find minimum cost spanning tree. Prims algorithm is used to find minimum cost spanning tree. Clear? All of you? So then what is the first step? What is the first step? Begins with single vertex X. Next add least cost edge u comma v to spanning tree. Repeat this edge addition step until tree contains n minus 1 edges. At the time edge addition, make sure that the added edge does not form a cycle at each step. The time complexity of the Prim's algorithm is order of n square, where n is the number of vertices in the graph. Order of n square. Remember all of you. Online bit. What is the time complexity of Prim's algorithm? Order of n square, where n is the number of vertices or nodes in the graph. Clear? So this is an example. All of you find the minimum cost spanning tree using Prim's algorithm from the following graph. Yes, this is the graph. Here simply, so which is the smallest edge from here starting with A. So which is the smallest edge, weighted edge, then A to C is the smallest. Am I right, all of you? Then C to B, yes. Then the next one C to D, next one D to E, next one is D to F. So simply A to C, B, next one is D, next one is E, next one is F. This is the minimum spanning tree while using Prim's algorithm. Am I right or not? So this is A to C to B to D, E, F. This is the minimum cost spanning tree. All of you, which is the smallest edge? Then the the traversing, which is the smallest edge from A to B or A to C, which is the smallest. Then there are two edges connected to A, which is the smallest A to C. The control moves this one. Then it one checks which is the smallest one. Two. It go to next one. Then the next one. Then there are eight. Eight is greater than, but eight is then this level. So three is less. But then here then C to D, then D to E. Next one D to F. Simply. So I will show the animation all of you. So I will show the animation. Please listen carefully. So this is the graph, all of you. This is the graph. I want to find the minimum cost spanning tree from this graph. All of you? Okay. This is the graph. I want to find the minimum cost spanning tree while using while using while using Kruskals algorithm. Okay, Prims algorithm. Sorry, Prims algorithm. So then this is the add node 0 to the tree. This is the 0 node. Yes. Next one. This is an algorithm. In this algorithm, check all edges from the nodes in a tree to nodes outside the tree. Find the smallest among such edges. Add this edge and its end point to tree end. Okay. So simply check all the edges of here. This is the node vertex. What are the edges are there? 1, 2, 3, 4. So weights are 19, 9, 3, 2. These are the weights. Which is the smallest weight? Then 2. The control go to 0 to 1. Clear? All of you. So see, all of you. Watch. The first one here starting with 0. So then what is the value? 2 is the minimum cost. Minimum. Yes. Then the go to next one, which is the smallest? 3. Next level is 3. Then the next level is 0, 2 to 4. Yes. Next level is 1, 4 to 6. Next level is 4, 6 to 4. Clear? Observe. All of you watch seriously. Then next one is 5. Next one is, which is the smallest element? 8. Next one it will 8. Okay. Search all the edges 9, 0 to 9, 3, 9. Okay. Next one is 40, 12. Okay. Next one is 19. So minimum cost spanning tree. So I repeat the same repeat. Watch. This is the graph. I want to find the minimum cost spanning tree of this graph. Okay, I want to find the minimum spanning tree from this graph using Prims algorithm. Using Prims algorithm. All of you. First 0. Node is 0. Search all the edges of, yes, which is the smallest? 2. Again search which is the smallest? Yes. Next one is 0. Next one 1, 4 to 6. Next level is 4, 0 to 6 to 10. Next level is 10 to 9, 5. So next level is 4 to 5, 8. Next level is 0 to 9, 0 to 3, 9. Next level is 12, 3 to 8. Next one is, yes. All of you. So this is the minimum cost spanning tree. So then 0 to 1, 0 to 2, 2 to 4, 4 to 6, 6 to 10, 10 to 9. Okay. Next one 0 to 3, 0 to 7, 3 to 8. So these are all unconnected components. Am I right or not? So finally, what are the leaf nodes? 9 is a leaf node, 5 is a leaf node, then 8 is a leaf node, 7 is a leaf node. Clear? All of you? Then 1 is also leaf node. So this is a tree, minimum spanning tree. So this is called minimum spanning tree. So to find the minimum cost spanning tree from the given graph. Clear all of you? Again, so watch. This is the graph. Starting with 0, it can check all these edges. Which is the low cost edge? 2. Control, select this one. First it can check this level. These are all the non-visited, yes, non-visited node edges. So which is the smallest weighted edge? This one. Next one, which is the smallest weighted edge? 3. Next one, which is the smallest? 0 to 0, 2 to 4. Next one 4 to 6, which is the smallest. Next one visited all these edges, which is the smallest, 4. Next one 5. Yes, 5. Yes, next one. Yes, 8. Next one is 9. Clear? So simply find the minimum cost spanning tree. Okay, all of you. So these links are terminated. These links are deleted. Why? These are not visited, not selected, not visited. Clear, all of you. So here tree, this is the root node. Then this is a leaf node. Then this is a branch. This is a parent node. This is also parent node. 7 is a leaf node. 8 is a leaf node. Then 5 is also a leaf node. 4 is a parent node. Then 6 is also a parent node. 10 is also a parent node. Then 9 is a leaf node. Clear? Simply. Then 14, 11, 10, 22. These are all 27, 23. These are all removed. So if we removed, then finally we will get a spanning tree, minimum cost spanning tree from the Prims algorithm, using Prims algorithm. Clear, all of you? Using Prims algorithm. Clear? So next one is Prims algorithm. So next one is, so yesterday we discussed Kruskals algorithm. Okay, ma, Kruskals algorithm. So this is the Kruskals minimum cost spanning tree algorithm. Kruskals algorithm is used to find the minimum cost spanning tree by adding one edge at a time. By adding one edge at a time. Procedure. This algorithm selects the edges for adding to tree in increasing order of their cost. The edge is added to tree. It does not form a cycle. It does not form a cycle. Clear? So the algorithm selects the edges for adding to tree in increasing order of their cost. The edge is added to tree. It does not form a cycle. Find the minimum cost spanning tree from the below graph. Clear? Using Kruskals algorithm. To find the minimum cost spanning tree from the below graph using Kruskals algorithm. So here simply these are all the edges. Edges means these are all the nodes. Here 0 to 5. The cost is, which is the cost? The cost is 10. Clear? So then here increasing order. Kruskals algorithm is used to find the minimum cost spanning tree by adding one edge at a time. Procedure. This algorithm selects the edges from adding to tree in increasing order of their cost. Increasing order of their cost. Here then here 0, 28 and 10, which is less 10. Here first one, here 10. So next one is clear, all of you, 10. So then the next one is, so which is the next one? 1, 6, 2, 3. 2, 3. It can select 2, 3. Then the next one is 12. The next one is 1, 6, 14. Clear? So then simply here 0 to 5. Next one is 1 to 6, 1 to 2. Next one 2 to 3. Clear? So then this one finally, then this is a Kruskals algorithm. This is a spanning tree, minimum cost spanning tree using Kruskals algorithm. Clear? Here 10, 25, here 0 to 5, then 4, 3, 2, 1, 6. Here 1, 2, 3, 4, 5, then 0. Clear? Here increasing 1, 2, 3, 4, 5. Okay. Here 6. Then, so see all of you. So I will show the animation. I will show the animation. Our next one is the Kruskals algorithm. This is the graph. So how many edges are there? 6 edges. Insert the edge, which edge increasing order of cost provided by the, they do not form a cycle path. Try it, insert edge of the lowest cost 5. which is that is 2 to 3. 2 to 3 is inserted at it does not form any cyclic path. Simply, okay. Now try to insert edge cost 6. Next one is 6. Here 2 to 4. Yes, next one is increasing order. After 6, which is the next smallest? 10. 10, but it is connected. 4 to 3, but it is connected. Simply avoid it. 4 3 is rejected as it forms a cyclic path. That's why avoid it. Next one is try it insert edge 11. 2 to 6. Yes, possible. Yes. And next one is, which is the next one is 18. Yeah, 16. 2 to 1. 14. Yes, 14. 4 to 6. But cyclic form. Avoid it. Cyclic form is created, but that is a graph. We want to generate a tree, minimum spanning tree. That's why avoid it. Rejected. Next one, 16. Yes. 1 to 16. Next one. All the edges are visited and nodes are visited. One node is there. Then 4 to 18. 4 to 5. 18. Yes. 4 to 5. Clear? Is there any edges there? No. Simply. So here 5, 6. Next one is 11. Next one is 16, 18 in increasing order. So I repeat the same. All of you. This is a graph. So how many edges are there? How many nodes are there? 6 nodes are there. 1, 2, 3, 4, 5, 6. These are the nodes. So to find the minimum cost spanning tree using Kruskals algorithm from this graph. First, which is the lowest edge? 2 to 3 is the lowest edge. Yes, 2 to 3 is the lowest edge. So this is separated. Next cost is 6. 2 to 4. Yes, it is possible. Yes, 2 to 4 possible. Next one is 3 to 4. Next one is 3 to 4. 10. Next cost is 10. 3 to 4. But it is not a tree. What is our aim, all of you? What is our aim? To generate or to calculate minimum, to find the minimum cost spanning tree using Kruskals algorithm. In the Kruskals algorithm, first, remember all of you, first here starting with lower to higher, like ascending order, the weights of edges, the weights of edges. You're starting, which is the lowest edge in this graph? Here 2 to 3. This is the lowest edge. Simply it's separated. Next is the which is the lowest edge? 2 to 4. This is 2 to 4. Next is the which is the lowest cost edge? This is the lowest weighted edge, 10. But it is a cyclic form. If it is a cyclic form, simply remove it. Why? Here, this is a graph. Graph is a connected components, whereas tree is not connected component, unconnected components. Remember, tree అనేది మనకి ఇలా కనెక్ట్ అయి ఉండదు, ఇది గ్రాఫ్ అయిపోతుంది. సో దెన్ ట్రీ అనేది ఇలా కనెక్ట్ అయి ఉండదు. Here root node, then branches. Okay, then there is no path between 3 and 4. That's why we want to generate a minimum cost spanning tree from the given graph using Kruskals algorithm. Simply avoid it. So here 3 to 4, this link is avoided. This way it is avoided. Avoid it means remove. Okay. So like, listen. Try to insert edge cost sign 4 to 3, but 4 to 3 is rejected as it forms a cyclic form. That's why it is rejected. Clear? Yes. Next one, try to insert edge of cost 11. Cost 11. So 11 equal to 6. Okay, then there is no cyclic form. It created edge. Leaf node of the 2. Next one. Next one is the 14. But it is created cyclic form. Then reject it. Reject it. 14 is rejected. 4 to 6 is rejected as it forms a cyclic form. Clear? Yes. Next one is, now try to insert edge of cost 16. So this is cost 16. Okay, no problem. It is not a cyclic form. It can create cost. Yes. Next one, 1 to 2. 1 to 2 is inserted as it does not from any cyclic path. So then the next one is 18. 18, 4 to 5. Yes, then there is no cyclic form. Clear? Then there is no cyclic form. It can create it. So simply, this is the minimum cost spanning tree while using Kruskals algorithm. Understood all of you? Then here, starting with lowest cost edge to highest cost edge, it should not be a cyclic form. If it is cyclic form, then reject the edge. Wait. Clear all of you? So here lowest 5, 6, then 11, then 16 and 18. So from increasing order. Yes, all of you? Then this is the Kruskals algorithm. Understood all of you? Kruskals algorithm. The minimum cost spanning tree is sum of all the edges is, which is 56. Here 5 plus 6, 11, 11 plus 11, 22, 22 plus 16, 38, 38 plus 50, 18, 56. The minimum cost of spanning tree is sum of all the edges, which is 56. Clear? All of you? This is 56. Kruskals algorithm. Okay, all of you. So then, here simply Prims algorithm and Kruskals algorithm. So again, I will show the Prims algorithm. No problem. Learn clearly. This is the most important algorithms. So this is Prims algorithm. In the Prims algorithm, so simply in the Prims algorithm, for minimum spanning tree, to find the minimum spanning tree using Prims algorithm. As node 0 to the tree, repeat. Check all edges from nodes in a tree to nodes outside the tree. All of you, this is an algorithm. Check all the edges from nodes in a tree to nodes outside the tree. For example, this is 0 is a node. This is first node. Then check all the outside, all the nodes, all the edges of the outside of the node. Clear? What are here? 2, 3, 9 and 19. First of all, we want to check all these. Which is the minimum one? Which is the lowest edge 2? Then it can select 2. Clear? Next one. Find the smallest among such edges. Which is the smallest one? 2. Next one, add this edge and its endpoint to tray. Okay. Then here, which is endpoint 1? Simply it is added. Clear? So this one again. Small. Ante. Next one, 3. Next level change. 2 to 4. 0. Level change 4 to 6. 6 to 10. Check all the outgoing nodes outside the tree. From nodes in tree to node outside the tree. Second step. Third step. Repeat. Step 1, step 2, step 3. Repeated again and again. Arrow mark is indicating. So finally, we will get a spanning tree. Clear? We will get a spanning tree from the given graph, which is highlighted lines. Those are the graphs, which is these color, violet colors, those are simply avoid. Okay, all of it, this is the spanning tree: 0 to 1, 0 to 2, 2 to 4, 4 to 6, 6 to 10, 6 to 9, 10 to 9. Then here 0 to 2, next one 0 to 3, 0 to 7, 0 to 3, 0 to 8, 0 to 7. These are all the unconnected components though. So this is the minimum spanning tree using Prim's algorithm. Minimum spanning tree using Prim's algorithm, Kruskals algorithm and Prim's algorithm. So over. Yes, sir? All of you clear? Yes or no? So then the next one is Warson's algorithms. So wait 1 minute. Warson's algorithms. Next one is shortest path algorithms. Shortest path algorithms. This algorithm is useful to find the shortest path between two vertices in the graph. Two vertices in the graph. So Dijkstra's shortest path algorithm. First algorithm is Dijkstra's shortest path algorithm. This is useful to find the shortest path from single source vertex to all other vertices in the graph. This is similar to minimum spanning tree algorithm. This is also similar to minimum spanning tree algorithm, minimum spanning tree Prim's algorithm. Like, so insert the first vertex into the tree. First vertex, like for example, a 0 node or a node or 1 node, which is the starting node. So from every vertex already in the tree, we examine the total path length to all adjacent vertices not in the tree. Select edge with minimum total path length and insert into the tree. Repeat step 2 until all vertices in the tree. Clear? So this is the given graph, example graph. So this is used to find the path of the graph using Dijkstra's shortest algorithm. So I will explain. First, watch the animation.
Dijkstra's algorithm is an algorithm for finding the shortest path between two given nodes in a weighted graph. The algorithm is used, for example, in navigators. When you set your destination, the navigator computes the fastest route to get there. The algorithm uses binary heap to store the distances to other nodes, so it doesn't need to be run more than once. At this point, you should be familiar with Dijkstra's algorithm, but it's necessary to understand the principles. Let's look at the algorithm through a simple example of a network of 6 nodes from node A to node F. We begin by setting the starting node's weight to 0 and every other node's weight to infinity.
So which is the
We
shortest
also
path
keep
here?
track of the already visited
A, B,
nodes.
E, F. That's it, shortest
First,
path.
we compare the distance from node A to node B to the weight of the node B.
Yeah, A, B, C.
Because the distance 2 is less than the weight of
Yes.
infinity, we set the weight of the node to 2.
Yes.
Then we do the same comparison on the node C. Because the weight of the node is greater than the distance,
A,
we
B, C,
update
E,
the weight
F,
to
one
4.
way, another way, A, B, E.
Now we set node A as a visited node and move to the node B. We start by comparing the distance to node D to the weight of the node D. Since 6 is less than infinity, the weight of the node D is changed to 6. Then we compare the weight of the node E to the distance and update node E's weight to 4. Finally, we compare the distance to node C to the weight of the node C. Because the weight 4 is greater than the distance 3, we update node C's weight to 3. We mark node B as a visited node and move to node C. From node C, we can compare the distance only to node E, since nodes A and B have already been visited. Since the distance to node E is greater than the weight of the node, we mark node C as visited and move on to node E. From node E, we compare the distances to the nodes D and F, since nodes B and C have already been visited. That way we set node F's weight to 6. Finally, we visit node D, but since none of the distances are less than the weight of the node, no weights are updated. At node F, there are no unvisited nodes left, so we just set node F as visited. Now when all of the nodes are visited, we can see that the shortest path from node A to F is through nodes B and E, with the total distance of 6. The time complexity for the Dijkstra's algorithm is OE log V, where E is the edges connected to each node, and V is the number of the nodes. Each node can be connected to V minus 1 nodes, hence the number of neighboring edges to each node is V minus 1. Finding and updating each neighboring node's weight in the min heap costs O log V time. Combining the above will give us OE log V. Dijkstra's algorithm is an algorithm.
Next, one more example. I will show you. Okay, understood all of you. So this is the Dijkstra's algorithm. This is used to find the shortest path of the graph. Yes. So all of you.
Dijkstra's algorithm is an algorithm for finding the short.
I will explain. Yes, in this graph.
So we just set node F
this graph
as visited. Now when all of the nodes are visited.
In this graph, so then first A is a node. Then you're starting from A. So what are the outgoing edges? 2 edges are there. Those 2 are weighted edges. The first A to B is 2. The A to B edge weight is 2. Then A to C weight is 4. It can compare. So which is the least? So we want to find the minimum path. Yes or no? Shortest path algorithm. Dijkstra's algorithm is the shortest path algorithm. This is used to find the shortest path from source to destination. So in this graph, which is the source one? A is a source one. F is a destination. F is a destination. I want to move from A to F. Then which is the shortest path? So we want to find shortest path, okay, from A to F. So that is also like minimum spanning tree. So it is also minimum spanning tree. We want to find minimum spanning tree, but which is the shortest path అనేది ఇక్కడ మనం find out చేయాలి. Your starting node is A. So how many edges are there? 2 edges. Those are bi-connected edges. Here the first A to B edge weight is 2. A to C edge weight is 4. Clear? It can compare. Which is the least one? 2. Then it can select this one here, A to B. Clear? A to B. Next one is all of you. Next one is, so what are the connected components, connected edges to be? This one 4, this one 2, this one 1, 3. So it can compare. Which one is the shortest one? Lowest cost edge, this one B to C. Then it can move from B to C. Clear? So next one, what are the connected components? Only one weighted edge is there. Then simply that is 3. Move from C to E. Clear? So then the next one, E to F. Then how many? Here simply then 4 are there, but 3 is visited. Then 2 is not visited, but B is also visited. Clear? B is visited. E to B is already visited. That's why no need to go that side. Then take this 2 1. So D is not visited and F is not visited. Then which is the minimum cost? Then 2 is the minimum weight. Then simply it will take E to F edge. Clear? So here which is the shortest path? Then A to B, B to C, then C to E, and E to F. This is the shortest path. Okay, ma. Then what are the weights? What is the cost? 2 plus 1, 3, 3 plus 3, 6, 6 plus 2, 8. This is the minimum cost spanning tree. So one more. So one more. So then here 2, 2, then 2. So one more. Here simply A2, 2, then B2, E2. Next one is E2, F, E2, F2. But here 6. But that is wrong. Because, so first of all, we compare all these edges. Which is the lowest one? We want to take that one. Clear? Then compare all these connected edges. But A is visited, no need to go that side. Then B is visited, no need to go that side. Then E is not visited. From it will select the third weight. Okay, then here C to E. Next, what are the connected components? What are the connected edges to E? Then 2, 3, 2, 3. But C is visited, B is also visited. So D is not visited and EF is not visited. Simply, which is the shortest among these two? 2. Simply move from E to F. This is final one. So here, so source is A, then destination is F. Clear? Destination is F. This is the shortest path of this graph. This is also spanning tree. Here A to B to C, then E, F. Okay. This is also unconnected. Finally, we will get unconnected components. Clear? Unconnected that is means that is called tree. All of you. So Dijkstra's algorithm is used to find the shortest path algorithm. Shortest path of the graph. Shortest path of the graph. Path means way. Path means way. Clear? Path means way. This is the Dijkstra's algorithm. Clear, all of you? Next tomorrow we will discuss more examples, more algorithms. Okay, all of you. Then I will show the next many algorithms remaining. All pair shortest path fluids algorithm. Next one example for all pair shortest path algorithm. Next one transitive closure Warsaw's algorithm, last algorithm. There are 2 algorithms available. Then Saturday, so finish this unit. Okay, all of you. Clear? All of you. Okay, bye. Thank you.